Good morning. Thank you for attending our Questline Academy webinar, Get Your Building Under Control, Better Performance with Building Automation Systems. My name is Levi Sanchez, and I'm the host of today's webinar. We'll be sending everyone a follow-up email within the next couple of days that will include a PDF of the PowerPoint presentation materials and the playback link to the recording of today's webinar. Before we begin, we wanted to cover a few housekeeping items. At the bottom of your screen are multiple application widgets you can use. All the widgets are resizable and movable, so feel free to move them around to get the most out of your desktop space. If you have any questions during the webcast, you can submit them through the Q&A widget. We'll try to answer these during the webcast, but if a fuller answer is needed or we run out of time, it will be answered later via email. Please know we do capture all questions. Some networks cause slides to advance more slowly than others, so logging off of your VPN is recommended. If your slides are behind, pushing F5 on your keyboard will refresh the page. You can find additional answers to some common technical issues located in the webinar tips and help widget at the bottom of your screen. We'll be conducting polls during the presentation, and we would really appreciate your participation. I will open our first poll now. Please be aware that you are not the only participant today. The names of the other attendees are not being shown to you for privacy. Now, let me introduce today's presenters. Mike Carter is a senior engineer for Questline Service. Mike has a BS in engineering and an MBA degree from the Ohio State University. He has worked with various EPRI centers supporting electrotechnology applications and spent 10 years conducting due diligence for technology commercialization. At the Questline Service, Mike writes articles for the newsletter, answers Ask an Expert inquiries, and develops webinars on energy topics. Jason Whitman is the Senior Energy Efficiency Program Coordinator for Indiana Michigan Power's commercial and industrial customers in Michigan, and has been in this role since May of 2016. He has a BS in Computer Information Systems from Colorado Christian University. Prior to joining the energy efficiency team, Jason worked at Indiana and Michigan's Cook Nuclear Power Plant for 5 years as an instrumentation and controls maintenance planner, and for 13 years in the Air Force, serving as a nuclear weapons launch officer and data and technology acquisition officer. And now I'll go ahead and turn it over to Mike, who will get things started for us today.
Thank you, Levi, and welcome everyone to our webinar today. This is actually the first in a series of 4 webinars that Indiana Michigan Power is offering its customers over the next few months. The second one will be on the topic of rooftop unit and chiller maintenance. I'm going to give you lots of checklists and ways to keep your HVAC system operating at peak efficiency. We'll, in the third webinar, talk about electric vehicles, the different types of vehicles out there today, the issues of range, their environmental emissions, etc. And then the fourth webinar will be covering the Energy Star Portfolio Manager tool, something that every facility should be taking advantage of. It measures and tracks your electric, gas, water consumption, and it even can score or grade you, and you can use that as a driver to get management to take energy efficiency challenges seriously. But today we're talking about building automation systems, another very fast-moving area. And I want to quote Thomas Hartman. He's an internationally known building control expert. He says there's 3 elements to effective building control. The first is control that effectively coordinates all the components of a system. The second is control that effectively distributes these resources to where the needs are in the building. And the third is control that continually evaluates system operation. And he goes on to say that each of these fundamental elements is sadly lacking in building and control systems as they're designed, implemented, and operated today. So we made a good start, but we can do a lot better. And hopefully at the end of this webinar, you'll be better equipped to consider that, and if you're implementing it yourself or if you already have, to improve the system that you have. So we're going to look at the background, the functionality, and architecture of typical building automation systems. Then we're going to focus on controls, the strategy. We think there's 3 levels of that: hardware, supervisory field controllers, sensors, etc. Introduce you to that. I'll talk about analytics, software, and then we'll move on to communication protocols, the user interface dashboards, and a lot of different best practices, such as ways you can avoid common mistakes. So a lot to cover today. We'll get going here. And when you use the term building automation system, you'll also hear the term energy management system. And we pretty much use those interchangeably. But technically, an EMS is a subset of a building automation system, which could also control people transport systems like elevators, escalators, building security, and even fire control systems. But we pretty much use those 2 terms interchangeably. There's 4 main core functions of a building automation system here: controls, operates, monitors, and provides. I'm going to let this video play here that will better explain that this morning.
An energy management system can help save you money by performing 4 basic functions that translate across a variety of applications. First, it controls the building environment. Simply put, an EMS delivers just the right amount of conditioned air, fresh air, and lighting specifically tailored for each type of space in your building, always with an eye toward energy savings. An EMS will operate your building functions based on a prescribed sequence of operations and control strategies. The EMS will react accordingly when specific conditions, like occupancy or amount of daylight coming in, change. By monitoring performance, an EMS can even implement corrective actions. And you can see it all right on the dashboard, so you know what's happening in your facility at all times. An EMS will also send you alarms and alerts that let you know if something needs attention in one of your systems. An energy management system provides control, operation, monitoring, and alerting, improving efficiency, lowering maintenance costs, increasing productivity, and enhancing safety in your facility.
All right. What is controlled by building automation systems? Well, pretty much almost any energy end-use equipment. I think in the future we'll see even renewable energy being controlled by building automation systems, backup generators, that kind of a thing. But it has a very wide scope. And how did we get here today? Well, back in the 50s, we introduced pneumatic systems, which of course are pretty prevalent today still as well. The 60s, we saw variable air volume systems being introduced and sensors. The 70s was the era of computerized analog energy management systems. The 80s, we got involved in direct digital control. The 90s, open protocols with supervisory devices, protocols like BACnet, which we'll talk about here in a little bit. And I think the 2000s is kind of the era of wireless and smart buildings. We talk about direct digital control. Prior to the 1980s, most building controls were either pneumatic, electric, or electronic analog. And so those sensor and control readings had to be converted from analog to digital, which resulted in some inherent lags in the responsiveness of these control systems. And so the industry introduced the direct digital controls around the 1980s and really revolutionized the controls industry. And so what manufacturers started doing was embed microprocessors into the electrical energy end-use equipment, such as packaged AC units or lighting panels, and that enabled direct digital control and communication to other network devices. And what are the parts of a building automation system, the components? There's 4 major areas, which is shown here: the server, field controller, input collector, output actuator. And then, of course, there's communication protocol and dashboards, which we're going to cover all these things. Here's a picture. Again, it's worth 1,000 words. If you look at the very bottom and go upward, there's a 4-level architecture typically that you'll run into. At the bottom, all the sensors and actuator levels are measuring temperature, airflow, pressure, even air quality like CO2 sensors, occupancy, even reaching outdoor temperatures. And then you have field control level devices. I've circled one here. We're going to look at examples of those. that take that data and do some decision making and then pass some of that data upward to the integration level. We call those supervisory controllers. And then finally the management level where our user interface is involved. And all this has to be connected together over various communication wired and wireless means. It is complex, no doubt. So why do we want to involve ourselves in building automation systems? Well, there's some great benefits to that. In terms of hitting and impacting your utility bill, it uses less energy. There's some debate about how much energy that is. I think it's reasonable to say 5 to 15% of your total energy use, that's electric and gas. I've seen numbers as double that, but I wouldn't want to bet the bank on that. But it can, in some cases, have that big of an impact. There's a number of what I call non-utility benefits, like reduce maintenance costs, because if you can better control your equipment, you're going to reduce short cycling. We're very hard on your equipment, actually damaging. And it improves indoor environmental quality, which impacts health and well-being, worker productivity. It makes it a nicer place to work, so it's easier to recruit and retain people. There's actually a report on this, 2017, called Improving Organizational Productivity with Building Automation Systems. It's supported by the Continental Automated Building Association organization, and they determined that building automation systems can have positive impacts on absenteeism, employee turnover, job performance, job satisfaction, health and well-being, and of course, what all facility managers like to see, fewer complaints. And if you look here on the right, it really is involving getting away from siloed systems, lighting, HVAC, whatever, and being more integrated. All right, poll question. Which of the following functions will a BAS system not perform? You got 5 choices there. It does 4 of those. One of these does not belong. So let us go ahead and I'm going to launch that and go ahead and give us your feedback on that. As you're doing that, I'm going to move forward here a little bit and talk about control strategy. I think there's 3 levels of building automation energy management systems that are out there today, and this is a great way to look at that. On the one hand, you could just be at the reporting, have a system that just is at the reporting level, and just looking at historic data, typically the day before. Or you can move into a little more sophisticated system that has an alerting type function. There's conditional rules involved. It does some fault detection and diagnostics, and it'll look at not only history, but it'll look at what's happening real time today. And then you could get into a system that's has advanced analytics. It's more proactive. It's predictive, so it's not only looking at yesterday, today, but it's looking at tomorrow. And here's a good example of that, just to kind of make that more concrete. This is a particular vendor. We're not endorsing this vendor, but it's a good example. This particular solution basically continuously monitors inputs, including weather, you see in the upper left corner, occupant comfort feedback in the lower right-hand corner, energy prices, demand response events. And based on all those inputs, it runs thousands of computations and arrives at what they consider the most efficient HVAC operating strategy for the next 24 hours. And so it'll make small changes in temperature and pressure to air handling unit that results in some big HVAC savings. So it's really adaptive and self-learning type of a system. Oh, so what's the top BAS hardware today? Well, I don't know, but I think Control Trends does. And what's that? Well, Control Trends is an organization created to provide HVAC and industrial controls professionals a place to learn and share information about the rapidly changing world of commercial and industrial controls. And we'll give you a link here at the end of the presentation as a resource. It's a great place to learn about building automation systems, hardware and software and trends. And for the last 6 years, Control Trends has hosted an awards program. And so they have a group of independent industry professionals that judge submittals by a lot of players in the industry. They hone it down to a short list, and that's what I'm showing you here today in this slide. And then they pick a winner. And so we'll depend on their judgment. I think a jury of their peers is pretty good judgment. And for plant equipment controller, more for industrial applications, you see a lot of the major players, Delta Controls, Distech, EasyIO, Honeywell, Siemens. These are all pretty well-known players in the industry. Maybe lesser known is actually the winners of this particular year. And we'll take a look at that here in a second. And so what's the following, which of the following functions will a BAS system not perform? Yeah, changing HVAC air filters. Now, while it won't physically change them, you might have pressure drop sensors that will tell you if it needs changed or not. So it's close on that, but it will operate and control and monitor and provide alerts and alarms. Those are kind of the four major functions. So, but this is the plant controller hardware that considered the best of the best. They're Internet Protocol enabled, compact, programmable, has physical inputs and outputs, integrated graphical visualization, and they're really starting to become pretty similar. We'll take a look under the hood of this in just a second. I just wanted you to know some of the names out there and what's considered some of the top products. Probably more applicable to most of you in the commercial area is BAS control systems. And here, you have the similar finalists we saw earlier, maybe a few new ones, but they tend to play in both areas. And the winner of this particular competition here was Johnson Controls Facility Explorer product. And they go by an FX80, FX20, FX60 type designation. Supports a full set of building automation features like scheduling, alarming, histories, data sharing, energy management, customized control routines. It has a graphical system user interface you can access with a web browser or remotely from any internet dial-up connection. And in fact, multiple users can concurrently connect to it, and it embeds security and presentation preferences managed through user profiles, login IDs, and passwords. Very important in terms of security today. And of course, that's the hardware aspect. It's going to get you a lot of data. Well, what are we going to do with all this data that this is all collecting? Well, that is handled by what we call building analytics software. And there's a number of, again, big players in this. Some of the hardware people at EasyIO, KMC are in that. But there's some other companies that are pretty popular, Coppertree, Anka Labs, and the winner, Sky Foundry, SkySpark. And this particular product, their solution they call Axon, A-X-O-N. It's an analytical engine that automatically processes rules and algorithms based upon your data to find what they call sparks. And sparks are simply things that matter. SkySpark then automatically generates visualizations, notifications, and reports that show the issue, time of occurrence, frequency, duration, and even the cost. And that's what kind of is shown here. You can see here there's an air handling unit cool failure, a heat treat temperature out of range, and you can see kind of the data that you can collect on here. And so they have over 500 built-in analytic functions to help you find what matters. That's what sparks are. And then you can either draw from that library, or you can create your own rules that target the specific needs of your facility. So it's very flexible. One of the reasons I think it was considered one of the top products. All right. This is one of the more tougher communication protocols issues. You have hardware has to communicate with other hardware, has to communicate with you and I as users of an automation system. So communication protocols are necessary. And in essence, a communication protocol is a formatting of how these things talk to each other. We can kind of think of that as the various languages we speak, like English, Spanish, or French. And so each language or protocol exchanges pretty much the same information, so temperatures, pressures, control signals, but it formats it in its own way, and therefore it can only be used by devices or software that speak that same language or protocol. And there's two types of general protocols: proprietary protocols and open protocols. The open protocols usually have the backing of some combination of corporations, user groups, professional societies, governments, and it works with a lot more equipment. Proprietary protocols often have to be used with just a small subset of equipment that's available for them. And so when you walk through this, you have de facto industry accepted protocols on different what we call layers. And Ethernet rules the physical layer. It's the lowest level in a communication protocol. And it defines how data packets are transmitted on physical things like cables, wires, etc. And then the Internet protocol is what we call a network layer. It's kind of a middle layer oriented protocol. And then you get into the proprietary and open protocols that are on top of those at what we call the application layer, which is the highest layer. And so you have like LawnWorks. It's an application layer protocol. Has the largest number of installed devices, over 90 million, and it covers, but it covers much more than building automation systems, HVAC, used a lot in the industrial sector. Then you have some more recent ones like KNX, but they're proprietary. Then you have open protocols like Modbus. It was developed way back in 1979 by Modicon. They manufacture programmable logic controllers. It has such a large install base and everybody uses it stigma attached to it that it still remains a strong standard today. And then you probably heard the popular BACnet open protocol. It's almost always associated with building automation systems and HVAC controls. And it supports 6 different network types which serve as the transport for BACnet messages. And each of these fills a particular niche in terms of the price-performance trade-off. And you can see ArcNet and BACnet IP and point-to-point, master-slave, token passing, etc. We're not going to get into that in great detail. What I find more interesting is what's under the hood of some of these field controllers, supervisory controllers. There's 4 basic metrics associated with these. They're either physical devices, objects, properties, or services. So when we talk about a physical device, it typically has a box like this, which has a universal. This one has 6 universal input and output points and 2 relay outputs. These 6 what we call universal input outputs, or universal in the sense that they can be individually configured to either be an analog input, an analog output, or even a digital input. And then when you get into objects, that's kind of an abstract concept, but it allows us to identify both the physical items like I/O points and then non-physical concepts such as software and calculations that's happening within this box, so to speak. So this device has 8 points of input-output, so there'll be 8 objects created plus 1 for the device itself. And BACnet defines over 24 standard objects, including things like loop, pulse, converters, calendars, that kind of a thing. And then each object type has a list of required properties, and optional properties. And all these properties has to be able to be read. Things like, what's the minimum limit of this? What's the maximum limit of this? Maybe it's a thermocouple or a CO2 sensor or whatever. What's the present value? That's the properties of those things. And finally, we need services built into these controllers so that one BACnet device can access data from another or command another device to take action. In order to learn, for instance, what the outside temperature is, we'd use a service called read property. And use a service like whois to know that you've added other devices on the system. Now these communicate and can be wired together or it can be a wireless. This is becoming much more popular. In the wireless topologies, you have things like point-to-point communication, just a full function device talking to a reduced function device, or you have a point to multi-point, just add more reduced function devices, or even a mesh network, which is more popular, or kind of a hybrid star mesh type network. So there are some different topologies there. Another often confusing, well, actually always confusing to me anyway, are the wireless communication protocol choices we have. And I've listed 5 here: Wi-Fi, Zigbee, Bluetooth, Mesh, ultra-wideband, and proprietary N-Ocean. They all are under an IEEE standard 802 something, and there's many more than this, but these are some of the more popular ones. And just to point out that they have different aspects or metrics, different metrics such as the battery life, if they have batteries. Wi-Fi is usually hardwired. A different throughput in terms of data transmission rates, kilobits per second. Different ranges. Some will go 50 feet, some are meters, and some will go 300. And maximum nodes that they can support, et cetera. So it pretty much comes down to what I always call horses for courses. There's not one solution that's always best for every situation. And so you're going to really need some help when you get into the details of this if you're going wireless and setting up your system. All right, well, let's launch another poll question. BACnet and Modbus are considered what kind of communications protocol? Are those open protocols or proprietary protocols? So I'll launch that here and let you chew on that for a second. Appreciate you giving us that feedback. And we'll look at the results of that here in a second. All right, well, we need to interact with all of this hardware, and we do that through a building automation system user interface. And what's involved with that? Well, you're looking at trending data. You're doing some scheduling. You're looking at real-time live graphic programs, and they do a really good job often of just even mocking up the actual air handler or fan or whatever, cooling tower, and giving you flows and temperatures and in real time. There's alarm and event information you'll be seeing. And so you can choose basically on an optimized user interface whatever information you want, and you can change it at any time. So if let's say you're having trouble with your chiller plant, well, you can bring in multi-trend graphs, the main system graphic, and then maybe a specific I/O panel into your dashboard and get a picture of how that system's doing at the moment. Or maybe you want to see comparative energy or utility usage. So again, you can bring in a variety of different graphs and charts and see immediately how that building's performing. Here's some tips on optimizing that user interface. Some of them are pretty common sense that aren't just commonly done. Consult people who are going to use this system. You're kind of given either a default user interface or even a blank slate, and you build this up and customize it the way you want. And you really do yourself a disservice if you're not intimately involving the end users, the people who are putting this together. For instance, you can design a template. You want to be able to find things. So the goal is make sure there's no more than 4 clicks to get into the system. So if you're looking for an air handler, you shouldn't have to go spend half an hour trying to get there. And in fact, the naming convention is real important in that regard. It might default to, let's say, an air handler, 107FC-EX2. You might improve that by calling it Air Handling Unit 101. Even better, it might be, this is the Northwest 4th Floor Air Handling Unit. And so just simple things like that really make a big difference. Use, when you're looking at temperatures, if it's a zone, call it ZNT, room, RMT, space, SPT, and very helpful to do that. All right, almost every one of you got this. BACnet and Modbus, very popular open communication protocol. A couple other tips here in terms of just overall building automation system best practices. You don't want a single point of failure, so it's best to really consider using multiple controllers rather than a single controller, so that one going down won't impact more than one mechanical system or one zone, for instance. Use products from one BAS manufacturer so that you really only have to deal with one major language, for instance. Or, hey, ask when you're evaluating this BAS offering, can you view the dynamic process as it happens in order to diagnose problems? Some will only let you look at historical data. Some will let you do that as it happens. Some other important things, can you edit the software without a controller reload or reboot? And that's really annoying to have to shut everything down and once you make some changes and then reboot the whole system. I think they're getting away from that, but I think there's still systems out there where you're required to do that. Is the controller software allow you to add functionality, like logical expressions? That's not in it as you got it. Some flexibility there. And then you'll see things like a naming convention tagging model being used. Project Haystack is known for that. It's kind of like hashtags for social media, but within building automation systems to help make those, so one building's BAS is very similar to another building in terms of naming conventions. All right, building automation systems, one of the big concerns is vulnerability to hacking and cybersecurity. And you're going to run into this with your IT department pretty quickly as you're trying to implement building automation systems. So here's some great advice from Phil Zito. He does a blog, Building Automation Monthly, and here's, I think, it's very wise advice. Separate the monitoring and the control functionality. Keep those separate. Use encryption. Most people would. Not everybody does. Close back doors to the server. I know we had, I read of an instance here of one instance where a major company was hacked because they had a printer out in the parking garage that allowed access to the server. Password control. Again, you'd think it would be very simple, first thing people would do, but the data, there's a Verizon data breach investigations report a couple years ago, and they determined that the legitimate user credentials were used in most data breaches, with some 63% of them using weak, default, or stolen passwords. So that's still a huge problem. All right. Here's the question. What if my BA system is hacked? It's probably a poor question because it's really not if these days, but it's when. And so what's your plan when your system is hacked? And so I came across this Secretary of Defense Cyber Command white paper that addressed this. The title's here, the Advanced Cyber Industrial Control System Tactics, Techniques, and Procedures. And so they have a 3-step process. It's much more detailed, of course, in the report. So basically they're saying you better be able to turn to previously developed mitigation procedures. In other words, plan ahead. So this is a pre-planned method of analysis. How are we going to even start to figure out what just happened? Your response to each expected outcome and a related course of action. So you really just think ahead what possibly could go wrong in terms of being hacked and what you can do about it. The second is preserve evidence of a cyber attack for forensic analysis, because unplanned mitigation actions can often destroy forensic evidence, and so you're not going to be able to know how it happened or how to protect yourself from future events. And then it goes on to compare existing versus baseline operational conditions of network entry points. And this includes hardware, and software. So you want a snapshot, just like maybe some of us go to the doctor and we get a heart scan, and then years from now the doctor will go back and say, well, how was your heart operating 5-10 years ago? How is it operating today? And you can figure out what's going wrong here. So you want to also be able to determine if you have any unusual internet protocol address or an unusual port protocol or service, or if an unusual port protocol or service is attempting to communicate with the BAS. So just odd things. It's like, why is this happening? Again, a lot of these big hacks into databases, you'll see a huge increase in traffic that's odd, and those are kind of things you need to be using. So download that. It's a great resource. Really want to be prepared. All right. What are some common building automation system mistakes? Again, this is from a veteran who's been in thousands of facilities, set up systems for hundreds of facilities, and this is worth spending a little more time on. So don't set the same schedule in every device. And about 70% of the buildings have just 1 to 3 schedules set for the entire building. Well, and a building has a lot of different spaces. You've got hallways, maybe a library, a gymnasium, or workout facility, classrooms, office space, lobbies. And so just big mistake is not tapping into the ability to customize the system, HVAC, lighting, whatever, for the different space types. Also, be careful using to be integrated by others in your purchase specification. Because what happens is nobody knows who the other is. And so people don't know if they're responsible for the integration. Then, if everyone's responsible, then, well, basically no one is. And it just doesn't get integrated. Another one is here, not resetting your temperature control set points based on demand. So if you don't reset the discharge air temperature when most of the VAV boxes aren't calling for cooling, this often can cause some of the boxes to kick into heating mode in the middle of July, for instance. Also, neglecting to perform regular database backups. And I've listened to this particular gentleman speak and tell horror stories of how he went in, he started changing some things. He never did, before he changed it, make sure there was a backup, and he lost the whole thing, had to recreate it from scratch. And so regular database backups, again, common sense, not necessarily common practice. What's the next here? In regard to database backups, one of the ways the Office C facilities save money is to have their BAS database on the same database machine that your IT group uses. And that's a great strategy, of course, until the new database administrator accidentally blows up your database. So you might want to keep those separate. All right, not tuning your proportional integral control loops. Problem is, over time, dampers get sticky, coils get a little gooey, and things just don't react as fast as they used to. And that can lead to hunting kind of condition with the control loops reacting too fast and overshooting the set point, et cetera. All right, another one here, don't set every alarm to the same priority. All alarms are equal. As, for instance, you're sitting there in front of your user interface and you just got 14 filter alarms, 5 exhaust fan status alarms, 3 zone temperature alarms, and 1 chiller down alarm. Of course, by this point, the chiller down alarm is on the next page of the alarm screen, and as they say, out of sight, out of mind. So you really have to prioritize what's really important, super important, and some things that aren't as important. You want to keep the most important things right in front of you there. So, also, never using trends. There's the BAS systems will always offer trend data, and it's a great way to troubleshoot your system, look for hidden faults, potential system issues that you can't pick out in live data. So just some really great, I think, advice there on BAS common mistakes that are made out there. How about this question? When should you upgrade? Let's say you have an older BAS system, and again, here's 4 good questions to ask if you should upgrade. And as you ask these 4 questions, it's important to start at the top level, the building automation server, and then work your way down to lower levels like the supervisory devices, field controllers. As you move through each layer, you ask the question, and when you discover the answer to one of these questions is no, in other words, does the BAS software support open protocols? No. Well, you need to make a decision about whether or not you want to take the risk of continuing to use that system. And the bottom line is, you ask yourself, are you spending more time to maintain your existing system than it would cost to upgrade the system? So this is just a good way to evaluate whether you should upgrade from what you have today. All right, last poll here of the day. Well, how valuable has this webinar been? We give you 5 choices. Really appreciate your input on that. Just give you just a second to give us your feedback on that, and we'll wrap up here. And so what are some of the conclusions that we can come to when we look at the building automation system landscape? Well, basically that direct digital control hardware has really become a commodity. They're all pretty much very similar. And software really is the heart of today's BAS systems. We see wireless expanding rapidly. What's next? You're seeing some, at least with the lighting area, communication over power lines. And knowledge of how to control HVAC really trumps vendor systems. In other words, you could have the Control Trends product of the year installed, in every facility, but if you don't have someone who knows how to control HVAC and lighting, etc., that fancy hardware is not going to do you a lot of good. And also realizes that building automation systems supports things like commissioning, lead verification, green building certification. It can really help you in those areas as well. So as you wrap up, we just want to leave you with some resources here. This Control Freak by Abel Ramirez, fantastic input here. Learn a lot about building automation systems. We mentioned Phil Zito, Building Automation Monthly. He has this one particular checklist called Building Automation Optimization Checklist. He compiled a list of 13 actions that someone with a new or existing building automation system can take to ensure their system's set up to support them. And he does a lot of background, tutorial BAS 101 type things as well. We talked about the Control Trends. Go to their website. Eric Stromquist interviews a lot of videos interviewing people in the industry about what's new, what's working, what's not. They had an interesting discussion a while back on the impact of millennials on building automation systems. And what they discovered was, I thought was very insightful, that while the trend has been in building automation systems to take control away from users, and put it up at that supervisory level and embed it into the hardware, millennials were like, where's the control? Why can't I control the air duct coming above my ceiling and the lights right above me? It's the way I want it. And so they're really seeing, in terms of the new workplace, flexible desks, et cetera, they're going to have to change some things. And finally, there's an older guideline, but still worthwhile, the ASHRAE Guideline 13, specifying building automation systems, that has recommendations for good practice, project considerations, detailed design options, and that kind of input. So with that, I'm going to turn it over to Jason. He's going to tell you a little bit about Indiana Michigan's energy efficiency programs and how it relates to building automation systems.
Well, thank you, Mike. Terrific presentation, and thank you for all of those who've been able to log on and attend today's webinar. I hope you found it useful. Mike covered a wide range of topics related to building control, building automation systems. And as a reminder, you will get this presentation after the webinar, so you can review these at your own leisure. So I would be remiss if I didn't take an opportunity to remind you, as our customers, that we have energy efficiency programs in both states, Indiana and Michigan. And our webinar today is actually sponsored, by our Michigan Education Program. And so I wanted to just kind of go over a few of our programs that we have. You're probably aware of them already. We have a small business direct install program geared for specific trade allies to interact with our small business customers. We also have our prescriptive programs, where we have over 100+ measures that you can participate in relating to lighting or HVAC or occupancy sensors, what have you. But our topic today, building automation systems, really relates to our incentive program, our custom incentive. And this is a little bit different than our other programs. Our custom program requires a pre-approval. So if you're interested in installing or putting in a building automation system for a customer, or if you're a customer, you're looking to have that done, please keep in mind that we require the application to be submitted and to receive a pre-approval to do that. So our applications are available on electricideas.com/work, and you see that website listed there. But also, if you have questions about specific programs or how you can apply, please reach out to us also at 888-444-9085, and we'll be glad to assist you in this process as well. For Michigan, we have a cap of $50,000 per site, $100,000 per company. And Indiana, a larger customer base there in Indiana. So the caps are they reflect that larger customer base at $150,000 and $300,000. So Mike had mentioned, one of the earlier slides that you've potential to have a 5 to 15% and maybe double, some say, for energy savings. And that custom program and our incentive will help you capture that energy savings via an incentive. So we hope that you participate. Hope that you found today's webinar informative. Our goal is to, inform you and educate you on current EE trends and topics, and then also to point you to our incentive and rebates program that can help you capture some of incentive dollars to cover the cost of that. That's all I have, Mike. I'll turn it back over to you, and I hope the rest of those who are participating will be able to participate in future webinars as well. Thank you, Mike.
All right. And we'll take a look at some of the questions here. If you have any, just type those in the Q&A text box. And we will, I think we had email our websites on some of the resources that are listed, or you'll be able to click on those and get those, or we'll put those in the email if they're not very plain. I had a question here about how common are BAS systems in commercial buildings today. And the Commercial Buildings Energy Consumption Survey, we call it CBEX, just came out. It's a little dated, 2012 data. That's the federal government. That's the best they can do in terms of the time it takes to do this right and get statistically valid data. But anyway, as of 2012, about 14% of 5.5 million buildings in the U.S. Have building automation systems. Now, of course, if you're a larger building, say larger than 100,000 square feet, about 50% of those have a building automation system. But most BAS buildings are a lot smaller, and they use packaged rooftop units. In terms of investing in building systems integration, there was a 2017 Johnson Controls Energy Efficiency Indicator Survey. They talked about 1,500 facility and management executives in the U.S., Canada, and 10 other countries, and they saw or recorded that about 46% had invested in building systems integration in the last year, and 80% plan to integrate their building systems in the future. So there's a great interest in this. Another question here on, can you give a kind of a example of someone who has integrated a building with building automation and what impact it had in terms of energy savings? So that information is not easy to find. There's a lot of general discussion about this, and it's kind of hard because a lot of times when you integrate a BAS, you're also doing many other things. You're upgrading your chillers, maybe adding economizers, upgrading your lighting, and so to pull out just the impact of a building automation system. But I did find one example, which was a single-story education facility, 19,500 square feet. It housed classrooms and hands-on laboratories and office space. They used cooling-only air terminals installed in each classroom, and the existing control systems were replaced with a building automation system. They implemented temperature and CO2 sensors, of course, that the BAS could use, and also implemented demand-controlled ventilation as well. optimize energy use. And this precise level of control resulted in about 34% reduction in kilowatt hours. And in addition, the building automation system provided trend information that alerted facilities staff to potential problems before they result in energy inefficiency. So that's a case where I mentioned, between 5 and 15%. Now, this is a recorded 34% reduction in using a optimized building automation system with the sensors and demand control ventilation that you could fairly easily implement with such a BAS system. All right, let's see. There's other questions here. What are some of the big barriers to building automation system implementation? I think that there's several. One is just lack of education and promotion, which we're trying to solve here today. Another can be data overload. It's just, well, I can implement this, and it's going to give me reams of data. What can I do with that? And again, we point you to some of the analytics software out there today that's really, been honed over the years, getting much better than it originally did, 5, 10 years ago, and very visual and very helpful to sort through that kind of a thing. Cybersecurity, of course, is another barrier, but there's, again, things you can do to make your BA system very cyber secure. I was at a meeting last year of mainly federal facility energy managers, facility managers, and sat in on several talks on this subject. And there are IEEE standards that now you can require some of the energy end-use devices to meet that specification and really achieve very secure BAS system cybersecurity. So there's high initial investment sometimes with a full system, particularly if you upgrade some of your hardware, your end-use hardware as well, rooftop units or whatever. And but those are being overcome, I think, fairly readily. So let me see if there's any other questions here that we need to cover. There are some questions that really are more related to a utility issue. We'll handle those offline after the facility ends. So, any experience implementing building automation system in small footprint retail locations that already have LED lightings and 1 or 2 rooftop units? And are you seeing energy facility savings enough to support the investment? I don't know if Jason, if you had any stories about smaller facilities. There are suppliers that specialize in building automation systems for smaller customers, and like I said, the hardware is becoming more of a commodity. Prices are dropping. You can see how many players are in the industry. That intense competition helps with that as well. So I think you can still do that. At least you can do on like RT unit, rooftop units, the software that will examine its operation and give you feedback, so there's just not a black box up there. The term escapes me right now of what that typically is referred to, but so, Jason, have you had any experience with BAS for smaller locations?
Not typically for smaller. We've seen it in the education setting, in larger commercial settings, but other than that, because of the cost and the number of systems that are integrated, it's usually for a larger facility.
Yeah. And again, one good place to investigate this, I highly recommend attending the AHR Expo. It's an annual expo, 6-7 football fields of HVAC primarily, and refrigeration equipment and control systems, building automation control systems for those things. So you can find what you're wanting there. So, but you can always ask, send an email to the utility and ask specifically maybe for some recommendations on those too. So let's see if we have any other things here. Are there BAS systems that only do lighting? Yeah, I don't think they'd be considered building automation systems, but there are certainly energy management systems for lighting, and so that's really the place to look for lighting, and that might be through a lighting panel and remote control of those zones and dimming and scheduling and occupancy and also so there are some that would be applied just for lighting. And what else do we have here? I don't see any others. So we're coming to the end of our time. There's just a few minutes left. If we haven't answered your question, we'll get to those offline, like I said. I'm going to turn it back over to Levi for some closing comments to wrap up today. Thank you for your attendance today.
Thank you, Mike. Levi had to step out for a moment, so I'll be closing us out.
Okay.
Sierra with Questline. We'd like to thank everyone for attending today's webcast. As a reminder, we will be sending a playback link with presentation materials in the next few days. If you have any additional questions or feedback, please feel free to email questline@webinars.com. And thank you again, and have a great day, everyone.